last session, we have discussed about the problems on concentration terms. So in this class, so the continuation part, I'm going to discuss some problems on Raoult's law of liquid-liquid solution. So before that, so remember some formulas based on Raoult's law of liquid-liquid solution. That is partial pressure of a component is directly proportional to mole fraction. That is P is proportional to X. P1 is equal to P01 X1 component 1 here. Component 2 here, P02 is equal to, P2 is equal to P02 X2. Formula X1 plus X2 is equal to 1. That is, sum of the mole fractions of all the components in the solution is always equal to 1. So based on that, so we have considered the problems. So first problem, based on Raoult's law of liquid solution. That is, heptane and octane form an ideal solution. So there are two components here. So one is, so problem number 1, heptane that is taken as component A, and one more component that is octane that is taken as component B. So at 373 Kelvin, the vapor pressure of the two liquid components are 105.2 kilopascal and 46.8 kilopascal respectively. So ಎರಡು component ನಿಮಗೆ vapor pressure ಕೊಟ್ಟಿದ್ದಾನೆ. So vapor pressure of pure component heptane, that is P0A is equal to, so heptane ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾನೆ ಅದರಲ್ಲಿ 105.2 kilopascal. So one more 46.8 kilopascal, that is octane vapor pressure. So that is P0B is equal to 46.8 kilopascal. So next, what you have to calculate? What will be the vapor pressure of a mixture of 26 gram of heptane and 35 gram of octane? And both the components are mixed together to get the ideal solution. So how much of heptane? That is 26 gram of heptane and 35 gram of octane is mixed with each other. So that gives the mixture. So we have to calculate the what will be the vapor pressure of the mixture. And so ಎರಡನ್ನು add ಮಾಡಿದಾಗ total vapor pressure ಎಷ್ಟು ಬರ್ತಾ ಇದೆ that we have to calculate. Mixture the vapor pressure ಅಂದ್ರೆ that we have to calculate P total. That we have to calculate total vapor pressure of the solution ಅಥವಾ total vapor pressure of a mixture. So ಎಷ್ಟು mix ಮಾಡಿದ್ದಾರೆ ಅದರಲ್ಲಿ? So that is 26 gram of heptane and 35 gram of octane ಅಂತ ಹೇಳಿದ್ದಾರೆ. That is mass of, so ನೋಡಿ ಇಲ್ಲಿ, so that is mass of W of heptane A. Heptane na A ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ. So W of A ಎಷ್ಟು ಗ್ರಾಮ್ ಕೊಟ್ಟಿದ್ದಾನೆ? That is 26 gram, and the mass of B is nothing but octane. So mass is 35 gram. So now, so first what you have to calculate? P total you have to calculate. So we know that P total is equal to PA plus PP. ಅಂದ್ರೆ ಎರಡು components to partial pressure first find out ಮಾಡಬೇಕು. So first find out ಮಾಡಬೇಕಾದ್ರೆ, so first we have to calculate number of moles. After that, mole fraction. So once you get the mole fraction, so we know the P0 values, that is A and P0 values, then you can calculate the partial pressure of each component, and then so adding of those partial pressure of each component will get the total pressure. So first, before that, so what is the heptane and octane formulas and molecular masses you have to calculate? So heptane, that is A. So A ke molecular mass C17. That is molecular formula C17H16. So molecular mass na find out ಮಾಡ್ಕೊಳ್ಳಿ. That is molecular mass of heptane A. A is nothing but heptane. So I'll calculate ಮಾಡ್ಕೊಂಡು ಎಷ್ಟು ಇರುತ್ತೆ? 7 into atomic mass of carbon 12 plus hydrogen 16 into atomic mass is 1. So that is equal to 7 to 14, 1 ಸಿಗುತ್ತೆ, 7 1 7 ಮತ್ತೆ 8, 84 plus 16. That is equal to how much? So that is 100 gram per mole is the molecular mass of, that is heptane, that is C7H16. So one more, that is octane, C8H18. So molecular mass of component B. Component B is octane here. So that is 8 into 12 atomic mass of carbon plus hydrogen 18 into atomic mass of hydrogen is 1. That is equal to 96 plus that is 18. That is equal to 114 gram per mole is the molecular mass of octane. So ಈಗ ನೀವು ಒಂದೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇರೋಣ. ಸೊ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಏನು ಮಾಡಬೇಕು? ಕ್ಯಾಲ್ಕುಲೇಟ್ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಕಾಂಪೋನೆಂಟ್ A, that is heptane. So number of moles of component A is nothing but molecular mass of component A, that is heptane, divided by molecular mass of component A. So adhe number of moles of component B is equal to mass of component B divided by molecular mass of component B. So calculate ಮಾಡ್ಕೊಳ್ಳೋಣ. So that is number of moles of component W of A ಕೊಟ್ಟಿದ್ದಾನೆ, that is mass of A, heptane is 26 gram divided by molecular mass of heptane, that is MA is equal to how much? 100 gram. So that is equal to, we'll get 0.26 moles. 0.26 moles is the number of moles of heptane. Number of moles of octane, that is component B, mass of B is 35 gram divided by molecular mass of component B, that is 114. So when you calculate this, what do you get? So number of moles of B is equal to 0.307 moles. That is the number of moles of component A and component B. Once you know the number of moles, in the second step, we have to calculate the mole fraction. So mole fraction of component A is equal to, so what is the formula? Number of moles of component A divided by number of moles of component A plus number of moles of component B. So that is equal to, what is the number of moles of component A? That is 0.26 divided by number of moles of component A 0.26 plus number of moles of component B, that is 0.307. So when you calculate the mole fraction of component A, that is heptane, so what do you get? 0.26 divided by, when you add this, you will get 0.567. So totally mole fraction of component A is equal to 0.458. That is the mole fraction of component A. So once you know the mole fraction of component A, you can easily calculate the mole fraction of component B by using the formula XA plus XB is equal to 1. That is, sum of the mole fraction of all the components in a solution is always equal to 1. So already we know the value of XA, then we can calculate XB. XB is equal to 1 minus XA, that is equal to 1 minus 0.458. So therefore, what is the value of XB here? So XB is equal to 0.542. That is XB. So now XA ಗೊತ್ತಾಯ್ತು, XB ಗೊತ್ತಾಗಿದೆ. So then number of moles ಎಲ್ಲ ಗೊತ್ತಾಗಿದೆ. Next P naught A ಗೊತ್ತಿದೆ, P naught B ಗೊತ್ತಿದೆ. Now according to Raoult's law, so what is the equation to calculate the total pressure? To calculate the total pressure, that is P total. That is the total vapor pressure of mixture is equal to, so partial pressure of component A plus partial pressure of component B. So partial pressure of component A, so according to Raoult's law, that is equal to P naught A into XA plus PB is equal to, what is it? P naught B into XB. So we know the component partial vapor pressure of two components A and B. Heptane and alkane two components to vapor pressure ಗೊತ್ತಿದೆ. That is equal to, what is the value of P naught A? P naught A is 105.2 kilopascal. That is 105.2 into, what is the mole fraction of component A? Mole fraction of component A is 0.458 plus, what is the value of P naught B? That is the pure component B, the vapor pressure is 46.8. 46.8 into, so XB, so mole fraction of component B, that is 0.542. So when you simplify this, so what do you get? Final vapor pressure of the total vapor pressure. So we have to multiply 105.2 into 0.458, that is 48.1816 plus 46.8 into 0.542. So that is about 25.3656. So when you add this, both the numbers, that is 73.547. That is the P total. So what is the unit of P total? That is the total vapor pressure. Total vapor pressure is nothing but vapor pressure of the mixture, which is obtained by the combination of or mixing of 35 gram of heptane and 26 gram of heptane. So here observe ಮಾಡಿ. So P naught A, that is 105.2 kilopascal. It is kilopascal. P naught B, that is in this kilopascal. X and X, we have the mole fractions. Mole fractions ಯಾವುದೇ unit ಬರೋದಿಲ್ಲ. So therefore total vapor pressure, that is in the unit kilopascal. So that is the total pressure, vapor pressure of a solution ಅಥವಾ vapor pressure of a mixture which is obtained by the mixing of 26 gram of heptane and 35 gram of octane. So that's about the problem. So ಸ್ವಲ್ಪ lengthy ಅನ್ಸುತ್ತೆ. So first step ಅಲ್ಲಿ ಏನು ಮಾಡಬೇಕು? First we have to calculate number of moles, then you can calculate mole fraction, and the third step only. So final step, that is 3 P total, that is the total pressure of vapor, so total vapor pressure of mixture. So that's about the problem number 1. Next, second problem. 100 gram of liquid A, molar mass 140 gram per mole, was dissolved in 1000 gram of liquid B, molar mass 180 gram per mole. The vapor pressure of pure liquid B was found to be 500 torr. Torr is the unit of pressure. Calculate the vapor pressure of pure liquid A and its vapor pressure in the solution if the total vapor pressure of the solution is 475 torr. So in the second problem, so collect the data. So what is the data given? That is the second problem. 100 gram of liquid A ಅಂತ ಹೇಳಿದಾನೆ. That is mass of component A is equal to 100 gram, and molar mass is also given. That is molar mass of component A is equal to how much? That is 140 gram per mole. Next one is was dissolving. So that is mixed with the 1000 gram of liquid B. That is mass of component B. That is equal to 1000 gram. And this molar mass is also given. That is molar mass of component B is equal to 180 gram per mole. So here some of the another information. The vapor pressure of pure liquid B. So that is P naught B. Pure liquid ಅಂತ ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ we are going to use the naught. P naught ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ component B ಇದು. So that is going to be 500 torr ಅಂತ ಹೇಳಿದಾನೆ. So 500 torr. So next, calculate the vapor pressure of pure liquid A. That is, we have to calculate P naught A, and one more you have to calculate, and its partial vapor pressure in the solution. So that is PA and PB. That is the partial vapor pressure of component A and B, which are coming from the solution. So and its vapor pressure in the solution. So nothing but we have to calculate PA, partial vapor pressure of the component A in the solution, and also we have to calculate partial vapor pressure of pure component A if the total pressure of the solution. So and also one more data, that is P total is equal to how much? 475 torr. 475 torr. That's the given data in the problem. So now first we have to solve the problem. First we have to calculate number of moles. So already given the mass and molar mass. First step only. So that is the data. So in the first step, we have to calculate number of moles of component A is equal to mass of component A divided by molecular mass of component A. What's the mass of component A? That is 100 gram divided by molar mass is 140 gram per mole. So 100 divided by 140. 100 divided by 140 is nothing but 0.714 moles. That is the number of moles of component A. Similarly, number of moles of component B is equal to mass of component B divided by molecular mass of component B. Mass of component B is given, that is 1000 gram divided by molar mass is also given, that is about 180 gram per mole. Gram cancel ಆಗುತ್ತೆ. So molar mass, number of moles of component B is about 5.55 moles. So once you know the number of moles, in the second step you can calculate the mole fraction. So in the mole fraction of component A is equal to number of moles of component A divided by number of moles of component A plus number of moles of component B. So here that is equal to mole fraction, number of moles of component A is 0.714 divided by again number of moles of component A, that is 0.714 plus number of moles of component B, that is 5.55. So once you calculate the mole fraction of component A, so what is the value you get? That is equal to 0.714 divided by adding of these two. So you get that 6.264. That is equal to, so when you divide these two, that is 0.114. That is the mole fraction of component A. So once you know the component mole fraction of component A, so you can easily calculate component B. That is XA plus XB is equal to 1. So that is XB is equal to 1 minus XA, that is equal to 1 minus, what is the value of XA? That is 0.114. Mole fraction unit barodilla. So that is equal to XB value is that is XB is equal to 0.886. That is mole fraction of component B. So mole fraction of component B ಗೊತ್ತಿಲ್ಲ, mole fraction of component A ಗೊತ್ತಿಲ್ಲ. So according to Raoult's law, so apply the equation, that is P total. So P total is equal to PA plus PB. That is the third step. So ಇಲ್ಲಿ ನಿಮಗೆ P total ಕೊಟ್ಟಿದ್ದಾನೆ. So what is the value of P total? That is 475 torque. That is 475 torque is equal to PA can written as P naught A XA according to Raoult's law, and PP can written as P naught B into XB. So 475 is equal to, so we have to calculate P naught A. So P naught A we have to calculate, that is vapor pressure of pure solvent, pure component A into XA, we know that is 0.114 plus. So P naught B is given, that is P naught B is equal to how much? 500 torque. 500 torque into XB is already calculated, that is 0.886. So that is 475 is equal to 0.114 into P naught A plus 500 into 0.886, that is equal to 443. So again so that is P naught A is equal to direct 475 minus minus that is become 443 divided by, let's say 0.114. So that is equal to 475 minus 443 divided by 0.114. So that is 32 divided by 0.114. So therefore P naught A is equal to 32 divided by 0.114. That is 280.70 torque. So that is the vapor pressure of tube component A. So one more you have to calculate, that is PA. So according to Raoult's law, fourth step, so you have to calculate PA. So PA is equal to P naught A into XA. So PA is equal to P naught A into XA. So already we calculated the P naught A, so we can easily calculate PA now. So P naught A is 280.70 torque into XA. We know that XA value is 0.114. That is equal to, so what is the value? That is around 31.99, approximately 32. 280.70 into 0.114, that is 32 brother. So here the P naught A, that is in torque, mole fraction, there is no unit, therefore PA is equal to 32 torque, that is the unit of partial pressure. So that's about the problem number 2. So here they are given the data, that is WA, NA, molecular masses and masses of component A and B. P naught B is given, P naught A, pure component A vapor pressure calculate ಮಾಡಬೇಕು, and also we can calculate the partial pressure of component A in the solution. And they are given another hit, they are given the P total, that is 475 torque. So first we have to calculate number of moles, then mole fraction. So next XA plus XB is equal to 1, then we can calculate the mole fraction of other component. Then apply the P total, Dalton's law of partial pressure apply ಮಾಡಿದ್ರೆ P total is equal to PA plus PB. Solve ಮಾಡಿ, so you will get P naught A. So once you get the P naught A, you can calculate PA by using the Raoult's law. PA is equal to P naught A into XA. So substitute the values, you get the value 32 torque. That's about the problem number 2. Next problem. Somewhat different problem. The vapor pressure of two liquid A and B are 450 and 700 mm mercury respectively at 350 Kelvin. Find out the composition of the liquid mixture. If the total pressure is vapor pressure is 600 mm mercury, also find the composition of the vapor phase. Composition of liquid mixture and composition in vapor phase. Composition is nothing but our intention is to calculate the mole fractions of the component. So mole fraction of component A and mole fraction of component B. Once you calculate the mole fraction in liquid, that is X and XB, liquid phase. Other vapor phase that is taken as a by A and YB. That can be calculated by using Dalton's law of partial pressure. So now move on to the problem. So given data, so vapor pressure of pure liquids A and B. Pure liquids are P0 A and P0 B. So that is third problem. P0 A is equal to what? That is 450 mm mercury. That is the unit of pressure again. So that again P0 B. P0 B is equal to how much? That is 700 mm mercury. That is the P0 A and P0 B. Vapor pressure of pure liquid component A and component B. Our intention is find out the composition of liquid mixture. Find out the composition of liquid mixture and then we have to calculate the mole fraction of each component. That is the composition, that's all. So X and XB in liquid mixture. So Xa and Xb are the mole fraction or composition of component A and B in liquid mixture. In liquid mixture. So again, one more thing is that if the total vapor pressure is 600 mm mercury, P total is equal to 600 mm mercury, and also we have to calculate composition in vapor phase. Composition of the vapor phase nothing but mole fraction Ya and YB that we have to calculate. This is the composition of mixture in vapor phase. In vapor phase. X and XB in liquid phase. Vapor phase is Y and YB. First we have to calculate XA and XB. That is very easy. So apply the Law's law and Dalton's law of partial pressure. So that is P total. That is P total is equal to partial pressure of component A plus partial pressure of component B. So according to Rolle's law, that is equal to P0 A into XA plus P0 B into XB. We know the value of P total. That is P total is equal to how much? 600 mm mercury. So before that, so we know the value of P0 A. That is P0 A is 450. P0 B is given. P0 B is 700. But we don't know the value of X and XB. XA XB ಎರಡು ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ so it is not possible to solve the both one. So ಎರಡನ್ನು ಸಾಲ್ವ್ ಮಾಡೋದು ಕಷ್ಟ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಏನು ಮಾಡಿ ಅಂದ್ರೆ XA ನ in terms of XB ಬರ್ಕೊಳ್ಳಿ, ಇಲ್ಲ XB ನ in terms of XA ಬರ್ಕೊಳ್ಳಿ. So ಯಾವ ರೀತಿ ಬರ್ಕೋಬಹುದು ಅಂದ್ರೆ, so we know that sum of the mole fraction of components in the solution is equal to 1. Very important. XA plus XB is equal to 1. So therefore given as XA is equal to ಏನು ಬರೀಬಹುದು 1 minus XB ಅಂತ ಬರೀಬಹುದು. Then substitute the value here. So P0 is given. So P0 is 450 mm mercury. XA is written as 1 minus XB plus P0 is given. P0 is how much? That is 700 mm mercury into XB. What is the components name of XB? XB name. So first we have to solve the XB. Once you get the XB value, you can calculate the XA. So therefore 600 is equal to n birthday 450 into 1. That is 450 minus 450 into XB, that is 450 into XB plus 700 into XB. So you can multiply, that is 600 is equal to 450 minus, so you can multiply XB common tagide, so what do you get? That is 450 minus 700. So you can multiply, best option. XP ತಗೊಳ್ಳಿ. So XP ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ತಗೊಂಡಾಗ so again ಏನು ಬರುತ್ತೆ, so minus plus ಆಗಿದೆ 450 minus ಏನು ಬರುತ್ತೆ 700. So that is 600 ಪೂರ್ತಿ ಈ ಕಡೆ ತಗೊಂಡ್ರೆ xb into 450 minus 700 is equal to 450 ಆಗಿ ಉಳಿಸ್ಕೊಳ್ಳಿ 450 ಈ ಕಡೆ ಬಂದ್ರೆ ಏನಾಗುತ್ತೆ minus 600 ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ 700 ಮತ್ತೆ 450 ಅಲ್ಲಿ ಮೈನಸ್ ಮಾಡಿ, ಸೊ xb ಹಂಗೆ ಇಟ್ಕೊಳ್ಳಿ ಇಂಟು 700 ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋದೆ ದಟ್ ಈಸ್ 250, 450 plus 250 that is 700 ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ 250, ಸೊ ಇಲ್ಲಿ 600 ಅಲ್ಲಿ 450 ಅಂದ್ರೆ that is become 150 minus 150, here also will get a minus 250. So therefore xb is equal to 150 divided by 250. So what is the value of xb? So xb is equal to how much? That is 0.6. That is the value of xb. So once you know the value of xb, you can calculate xa. That is xa is equal to 1 minus xb. That is xa is equal to 1 minus xb. 1 minus, what is the value of xb? That is 0.6. So therefore xa is equal to 0.4. That is the mole fraction of component A and B. What is the mole fraction of component A and B? That is xa and xb. xa and xb now ಯಾವ solution ಅಲ್ಲಿ? That is the composition of the components mixture in a liquid phase. So one more you have to calculate composition in vapor phase. So composition in vapor phase can be calculated by using the Dalton's law. So what is it? According to Dalton's law, PA is equal to YA into P total, where YA is the mole fraction of component A in a vapor phase. So that is PA first vertical. What is the value of PA? So PA calculate ಮಾಡ್ಕೋಬೇಕು ನೋಡಿ, ಇಲ್ಲಿ PA calculate ಮಾಡಬೇಕು ಅಂದ್ರೆ P0 into XA ಮಾಡ್ಕೋಬೇಕು. So one more, so PB is equal to YB into P total. So ಇಲ್ಲಿ ನಾವು ಇಂಗ್ಲಿಷ್ ಏನಪ್ಪ ಅಂದ್ರೆ YA and YB ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. So before that, so first we have to calculate PA and PB. So PA is equal to, so what is PA? So PA is equal to P0A into XA. So what is the value of P0A? So P0A is given, that is 450 mm mercury, and XA is given. So XA calculate ಮಾಡಿದ್ವಿ, XA is equal to 0.4. That is equal to, what is the value of PA? So PA is equal to, that is 600. 450 into 0.4, that is 600. Okay, so what is what happens? So you need that. So in case mm mercury pressure. So PA ಗೊತ್ತಾಯ್ತು ಅಂದ್ರೆ you can calculate YA now. So that is by using this equation. So what is it? YA is equal to PA divided by P total. So what is the value of PA? That is 600 mm mercury divided by P total is given. So what is the value of P total? That is 600 mm mercury. Sorry, P total is again 600. Sorry. 450 into 0.4 is 180 mm mercury. So here 180 divided by 600. That is, sorry, 180 divided by, that is equal to 0.3. That is the mole fraction of component A in a vapor phase. So ಈಗ component A ದು ನಿಮಗೆ mole fraction ಗೊತ್ತಾಗಿದೆ. Similarly, so component B ಬೇಕು ಅಂದ್ರೆ sum of the mole fraction of component A and B, whatever it may be liquid phase or in the vapor phase, ಯಾವ ತರ ಆಗಿರಲಿ, sum of the mole fraction of component A and B is always equal to 1. So YA value ಗೊತ್ತಿದೆ, that is YB, mole fraction of component B is equal to 1 minus YA, that is equal to 1 minus 0.3, that is equal to 0.7. That is the mole fraction of component B. So here the question is to calculate the mole fraction composition of the liquid phase and composition in vapor phase. Nothing but mole fraction of component A and B in a liquid phase, that is X and XP, and you can calculate the mole fraction of component B in vapor phase, that is YA and YB. So that is Y and YB can calculate by using the partial equation of component A and partial equation of component B. So PA value ಗೊತ್ತಾಯ್ತು ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ YA ಕಂಡುಹಿಡಿಯಬಹುದು. YA ವೆಕ್ಟರ್ ಇಕ್ವಲ್ ಟು 1. ಸೊ ಇಲ್ಲಾಂದ್ರೆ ಈ ಫಾರ್ಮುಲಾ ಹಾಕೊಂಡು ಸೊ ಹೇಗೆ ಕಂಡುಹಿಡಿಯಬಹುದು, YB ಅಂದ್ರೆ PB ಫಸ್ಟ್ ಕಂಡುಹಿಡಿಕೊಂಡು, ಸೊ PB ಗೆ ಏನು ಮಾಡಬೇಕಿದೆ, YB is equal to PB divided by P total ಹಾಕೊಳ್ಳಿ, ಅವಾಗ ಏನು ಸಿಗುತ್ತೆ, YB ಸಿಗುತ್ತೆ. ಅಗೇನ್ ಅದನ್ನ YA ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು, 1 minus YB ಅಂತ ಹಾಕೊಳ್ಳಿ. ಸೊ ಇದನ್ನು ಬೇಕಾದ್ರೆ ಅದು ಒಂದು ಮಾಡಿಕೊಂಡು ಸಮ್ ಆಫ್ ದಿ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 ಅಂತ ಅಪ್ಲೈ ಮಾಡ್ಕೊಂಡ್ರೆ ಯು ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ ದ ಕಾಂಪೋನೆಂಟ್. ಸೊ ಇದನ್ನು ಬೇಕಾಗಿಲ್ಲ ನಿಮಗೆ. So that's about the problem. So ಇಲ್ಲಿ ಒಂದು ಸ್ವಲ್ಪ ನಿಮಗೆ ಈ ತರ ಕ್ವೆಶ್ಚನ್ಸ್ ವೇಪರ್ ಫೇಸ್ ಅಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಕ್ಕಂಥ ಕ್ವೆಶ್ಚನ್ಸ್ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಜಾಸ್ತಿ ಕೇಳ್ತಾರೆ, ಬಟ್ ಈಸಿಯಾಗಿ ಡಿವೈಡ್ ಆಗಂತ ಒಂದು ನಂಬರ್ಸ್ ಅನ್ನು ಕೊಟ್ಟಿರ್ತಾರೆ. So vapor phase ಅಲ್ಲಿ ನೀವು mole fraction ಅಥವಾ composition ಅನ್ನು ಕಂಡುಹಿಡಿಯಬೇಕು ಅಂದ್ರೆ that is we are going to use this formula, that is PA is equal to YA into P total. ಇನ್ನೊಂದು component ಗೆ PB is equal to YB into P total. X ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ರೆ that is a mole fraction in liquid phase, Y ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ರೆ that is a mole fraction in vapor phase. So that's about the problem number 3. Next, problem number 4. The problem is page number 46 ಅಲ್ಲಿ ಇರುತ್ತೆ ನೋಡಿ. Study material ಅಲ್ಲಿ 46 page number 46 ಅಲ್ಲಿ ಇರುತ್ತೆ. So next, vapor pressure of chloroform, that is CH3 and dichloromethane, that is CH2Cl2 at 298 Kelvin or 200 mm mercury and 415 mm mercury respectively. Calculate the vapor pressure of the solution prepared by mixing 25.5 gram of chloroform and 40 gram of dichloromethane at 298 Kelvin, and also we have to calculate mole fractions of each component in vapor phase. It's a lengthy problem. So first, select the data. What are the given components? One is chloroform, another one is dichloromethane. Problem number 4. Given data, there are two chloroform is there, that is chloroform formula CHCl3, that is taken as component A. Dichloromethane, that is CH2Cl2, that is taken as component B. Vapor pressure of both chloroform and dichloromethane is given, that is P0A and P0B. What is P0A? A referred for chloroform, that is about 200 mm mercury, 200 mm mercury, and one more, that is 415 dichloromethane to 415 mm mercury. So what you have to calculate? That is question 1 in calculate to calculate the vapor pressure of solution. So ಎರಡನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ನಿಮಗೆ ಎಷ್ಟು ಮಿಕ್ಸ್ ಮಾಡಿದರೆ 25.5 gram of chloroform and 40 gram of dichloromethane. ಅಂದ್ರೆ ಇಲ್ಲಿ mass of chloroform A, that is equal to 25.5 gram, and mass of component B, that is dichloromethane, is 40 gram. So ಇಷ್ಟಿಷ್ಟು ಗ್ರಾಮ್ ಅನ್ನ ಕಾಂಪೋನೆಂಟ್ ಎ ಅಂಡ್ ಬಿ ಕ್ಲೋರೋಫಾರ್ಮ್ ಮತ್ತೆ ಡೈಕ್ಲೋರೋಮೀಥೇನ್ ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ we get the solution. ಆ solution total vapor pressure given, that is vapor pressure of solution, that is we have to calculate P total, that you have to calculate. And one more thing is mole fractions of each component in vapor phase. So one more, that is second, so we have to calculate YA, mole fraction of component A, that is chloroform in vapor phase, and YB, that is mole fraction of component B, dichloromethane, that is the mole fraction in phase, that is in vapor phase. That you have to calculate. First you have to calculate P total. So P total na kalkulatebeku andre by applying Dalton's law. But Dalton's law apply ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ mole fractions ನ ಕಂಡುಹಿಡಿಯಬೇಕು ಕೊಡಬೇಕು. Mole fraction ನ ಮುಂಚೆ number of moles ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ A ಮತ್ತು B ಗೆ molar mass ಗೊತ್ತಿರಬೇಕು. So first molar mass of A ಕಂಡುಹಿಡಿಯೋಣ, that is molar mass of A. So that is component A is chloroform. Chloroform carbon 1 into atomic mass is 12 plus hydrogen 1 into atomic mass is 1 plus chlorine 3, atomic mass of chlorine is 35.5. Atomic number is 17, atomic mass is 35.5, that is Ma, molecular mass of chloroform. So that is equal to, so how much? So add one to it, that is 12 plus 1 plus 5 3s are 15, 1. So again 5 3s are 15 plus 1, 16, again 1 3 is 9 plus 1 10. So we leave 1 together, 106.5. So total add ಮಾಡ್ಕೊಂಡ್ರೆ So that is equal to 119.5 gram per mole. That is molecular mass of component A. That is for chloroform. So similarly, what we calculate molecular mass of component B, that is MB is equal to dichloromethane. That is dichloromethane one carbon is there. So 1 into 12 plus, so hydrogen is there. So that is 2 here. So 2 into atomic mass is 1 plus chlorine is there. That is 2 into 35.5. So total, what is the molecular mass of component B? That is for dichloromethane. So that is about 85 gram per mole. That is 85 gram per mole is the molar mass of component B, and molar mass of component A is 119.5. 35.5 into 2 is 71. 71 plus 2 is 73. 73 plus 12, that is 83 plus 2, 85. So this is the molecular mass of component A and B. So next step, start ಮಾಡಿ. Step 1, number of moles of component A, that is equal to mass of component A divided by molecular mass of component B. WA divided by M. What is the molecular mass of component A is given, that is component is chloroform, that is 25.5 divided by molecular mass of component A is 119.5. So therefore, is the number of moles. So calculate mole error, that is 0.213 moles. So that is the 0.213 moles, the number of moles of component A. Similarly, number of moles of component B is equal to mass of B divided by molecular mass of B. But the mass of B is given, that is 40 gram divided by, what is the molecular mass of B? That is 85 gram per mole. So gram cancel, the mole 40 divided by 85, that is 0.470 moles. That is the number of moles of component A and component B. Now you calculate second step, mole fraction. So XA is equal to NA divided by NA plus NB. Number of moles of component A divided by total number of moles. That is equal to number of moles of component A 0.213 divided by 0.213 plus number of moles of component B 0.47. That is equal to calculate 0.213 divided by 0.683 0.311, that is the mole fraction of component A. So again, mole fraction of component A plus mole fraction of component B is equal to 1. Where N we refer for chloroform and dichloromethane. So you can easily calculate XP. XP is equal to 1 minus XA. So that is equal to 1 minus XA value is 0.311. Therefore, XP is equal to, so 1 minus 0.311, that is 0.689. That is the mole fraction of component B. So now we can calculate P total. So P total calculate, that is third one. P total is equal to PA plus PB. And P total ಕಂಡುಹಿಡಿಯಬೇಕು. So PA is nothing but partial vapor pressure of component A, that is chloroform, partial pressure of component B, that is dichloromethane. So according to Raoult's law, PA is equal to P naught A into XA, PB is equal to P naught B into XA. That is equal to, what is the value of P naught A? That is 200 mm mercury into, what is the value of XA? XA is 0.311 plus, what is the value of P naught B? P naught B is given, that is 415 mm mercury into, what is the value of XP? XP is 0.689. So calculate what is the value of P 200 into 0.331, that is 62.2 plus, so 285.93, 450 into 0.689, that is adding these two, so we'll get the P total. So P total is equal to how much? 348.135 mm mercury. That is the value of P total. P total is nothing but vapor pressure of the mixture or vapor pressure of solution. That we have to calculate. First one adene, that is vapor pressure of solution by mixing octane by mixing 25.5 gram of chloroform and 40 gram of dichloromethane. So that is one point. So next time basically you have to calculate Ya and Yb. So Ya and Yb calculate. That is the vapor mole fraction of component A and B in vapor phase. So that is 2 in calculate. So initially is that is Pa is equal to Ya into P total. So therefore Ya is equal to Pa divided by P total. So what is the value of Pa? Pa is equal to P0 into Xca. That is 200 into 0.311. So what do you get? 62.2. That is 62.2 divided by P total. So P total calculate that is 348.135. 348.135. So therefore, what is the value of Ya? So Ya is equal to 0.178. That is the mole fraction of component A in vapor phase. So once you know the mole fraction of one component, you can calculate the other component. That is Ya plus Yp is equal to 1. That is sum of the mole fraction of all the components in the solution is always equal to 1. So therefore Yp is equal to 1 minus Ya. 1 minus Ya, that is 0.178. That is Yp is equal to, what do you get? So that is equal to 0.822. That is the mole fraction of component P. So in this problem, so intention is to calculate the mole fraction vapor pressure of the solution. That is total pressure. That is nothing but total pressure of the mixture, total pressure of solution, and the mole fractions of each component in vapor phase. Vapor phase ಅಲ್ಲಿ mole fraction is equal to Ya and Yb. That is Y ಅಂತ ತಗೊಂಡ್ವಿ, X ಅಂತ ತಗೊಂಡ್ರೆ there is a mole fraction in liquid phase. So in mole fraction in vapor phase, Ya is equal to P by P total. That is according to Dalton's law. Partial pressure is equal to mole fraction into P total. This mole fraction is component A. Mole fraction of this component A in vapor phase, Ya calculate ಮಾಡ್ಕೊಳ್ಳಿ. And sum of the mole fraction of components in any phase, ಯಾವುದೇ phase ಅಲ್ಲಿ ತಗೊಳ್ಳಿ, sum of the mole fraction of all the components is always equal to 1. So Ya value ಗೊತ್ತಿದೆ, then you can calculate Yb. So Yb is equal to 0.822. That is composition. Ya and Yb is a mole fraction of each component in vapor phase, ಅಥವಾ composition of the mixture in a vapor phase. That is Ya and Yb. So that's about the problem number 4. Next problem number 5. At 29 Kelvin, the vapor pressure of pure benzene is 0.256 bar, and the vapor pressure of the pure toluene is 0.0925 bar. If the mole fraction of benzene in solution is 0.4, calculate the total pressure of the solution. And second one, calculate the composition of the vapor phase in terms of mole fraction. So again, same problem. So question number 5, data correct ಮಾಡಿ. So what is the data? So there are two components here. Question number 5. One is benzene and another one is toluene. There are two components. So two components ನಿಮಗೆ vapor pressure ಕೊಟ್ಟಿದ್ದಾನೆ. So here benzene is taken as B ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, toluene is taken as T ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. So that is P0P, vapor pressure of pure component of benzene, that is 0.256 bar. 256 bar. Bar is again rate of pressure, and again the vapor pressure of pure toluene, that is taken as P0T. P0T, that is about 0.0925 bar. So if the mole fraction of benzene in solution phase ಅಂದಾಗ that is taken as X. X is the mole fraction. So benzene the mole fraction ಕೊಟ್ಟಿದ್ದಾನೆ, that is mole fraction of benzene is equal to 0.4. What do you have to calculate? Total pressure, total vapor pressure of solution, that is P total we have to calculate. And one more thing you have to calculate the composition of the vapor phase in terms of mole fraction and rate. So second one, so that is mole fraction in vapor phase, that is Y composition, that is YP, you have to calculate mole fraction of component benzene in vapor phase and mole fraction of component toluene in vapor phase. This is the mole fraction in vapor phase that we have to calculate. So first P total calculate mode. So just apply the Raoult's law and Dalton's law of partial pressure. So that is P total is equal to P of benzene divided by P of toluene. That is partial pressure of component benzene plus partial pressure of component toluene. So according to Raoult's law, PV is equal to P naught P into XP plus Pt is equal to P naught T into Xt. So that is component toluene. So that is equal to P naught P, that is vapor pressure of pure component benzene, 0.256 bar into Xp. So that is the mole fraction of component benzene, that is equal to 0.4 plus P naught T, pure component toluene, 0.0925 into Xt value, that is mole fraction of component toluene in solution phase. But we know that sum of the mole fraction of components is equal to 1. So therefore Xt is equal to 1 minus Xp. 1 minus Xp is nothing but mole fraction of component benzene, that is mole fraction is put in 0.4, that is equal to Xt is equal to 0.6, that is the mole fraction of the toluene. Then substitute the value, that is 0.6. So calculate modulate. So 0.256 into 0.24, that is 0.1024 plus 0.095 into 0.6, that is 0.0555. That is equal to P total. So P total is for that 0.1579 bar. So here bar is in it, ಇಲ್ಲಿ 0.256 bar ಇರುತ್ತೆ, mole fraction unit ಇಲ್ಲ, ಇಲ್ಲಿ 0.0925 bar, 0.6 again mole fraction unit ಇಲ್ಲ. So total reference ಕೊಡ್ತಾರೆ 0.1579 bar ಕೊಡ್ತಾರೆ. So that is about the total vapor pressure of the solution. So now the second one is you have to calculate so mole fraction of component B, so that is benzene and toluene in a vapor phase by using so PP is equal to YP into P total, that is according to Dalton's law. So then YP, mole fraction of component benzene in vapor phase, that is equal to PP divided by P total. So what is the value of PB? So PB is P naught P into XP. P naught P into XP put it is 0.256 into 0.4, that is about 0.1024 divided by P total we have calculated 0.1579. So that is equal to, so we will divide by, so we will get 0.6485. That is the mole fraction of component benzene in vapor phase. Then we can calculate component T, other the mole fraction vapor. So by using YB plus YT is equal to 1. Sum of the components, mole fraction of the components in any phase is always equal to 1. So therefore YT is equal to 1 minus YB. So that is equal to 1 minus, what is the value of YB? 0.6485. So therefore mole fraction of component T, that is toluene, is equal to 0.3515. That is 0.3515, and also we have to calculate, sorry. Oh wait. Okay, 0.3515. That is the mole fraction of the component T, that is toluene in vapor phase. In the given problem, so they given the vapor pressure of pure benzene and pure toluene. So that is P naught P and P naught T in the mole fraction of benzene in solution phase. Solution phase of liquid phase, the mole fraction is taken as X. That is Xp is equal to 0.4 again. So you can calculate Xt also. Xp plus Xt is equal to 1. Then Xt is equal to 0.6. So for this is to calculate P total and also mole fraction of component B, that is benzene and toluene in vapor phase. So apply the formula P total is equal to PV plus PT. There are two components P and C and toluene. PV is equal to P naught into XP according to Rolle's law. PT is equal to P naught into XP again according to Rolle's law. Substitute the values, so we'll get the P total there. So then we can calculate YB, that is the mole fraction of component B in a vapor phase. YB is equal to PV divided by P total. This is according to Dalton's law. 0.21024, 0.1579. Calculate one, you get 0.6485. So once you know the value of YB, mole fraction of one component in any phase, so you can calculate the mole fraction of another component. Just by knowing sum of the mole fraction of two components in any phase is always equal to 1. Then we know the value of YB already. So YB is equal to 1 minus YB and YB is equal to 0.3515. So that's about the problem number 5. So these are the problems based on Rolle's law of liquid solution. Of course, in competitive exams also, they will ask the questions based on this lengthy answer that, but ಇಲ್ಲಿ ಯಾವುದೇ ಬೇರೆ problems, ಬೇರೆ formulas ಅಂತ ಏನಿಲ್ಲ, just PA total is equal to PB, PA plus PB ಅದನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. According to Rolle's law, PA is equal to P naught into XA ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ, and XA plus XB is equal to 1. Sum of the mole fractions of all the components is equal to 1. ಆ ಫಾರ್ಮುಲಾ just ಯೂಸ್ ಮಾಡೋದು. ಅದರ ಜೊತೆಗೆ mole fraction ಮತ್ತೆ number of moles ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಗೊತ್ತಿರಬೇಕು. Number of moles is equal to mass divided by molar mass. Mole fraction is equal to number of moles of that component divided by total number of moles. So based on these equations, so we can do the problems based on Rolle's law of liquid solution. That's about the problems on the Rolle's law of liquid solution. Idra base mele matte workout anta heli ade page alli page number 46 in the study material. So adralli innu 4 problems ide. So adu ide base mele ide. So adna workout ಮಾಡ್ಕೊಳ್ಳಿ. So if you have any doubts, so call me. So that's about the problems. So that is next concept in the solution chapter, that is colligative properties. So in part 1 ಇಲ್ಲಿ work ಏನಾಗಿದೆ assured proofs ಏನಾಗಿದೆ, that is taken as part 1, and part 2 is colligative properties. So ಅದರಲ್ಲಿ colligative properties ಅಂದ್ರೆ ಏನು, what are the examples for colligative properties? 4 colligative properties ಬರುತ್ತೆ. So ಆ colligative properties ನ one by one, so we have studied in detail. So ಅದರಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಒಂದೊಂದು colligative propertyಗೂ ಒಂದೊಂದು problems ಬರ್ತಾ ಹೋಗುತ್ತೆ. So again there are problems on colligative properties. Next concept in the solution chapter is, that is colligative properties. Next concept is colligative properties. So what are the colligative properties? So colligative properties are the properties of the solution which contain non-volatile solute. So these are the properties of solutions containing non-volatile solute. So on these properties, colligative properties are those which are mainly depends on number of solute particles but not on the nature of the solute particles. ಈಗ ಏನಾಗುತ್ತೆ, ನೀವು ಯಾವುದಾದ್ರು ಒಂದು ಸೊಲ್ಯೂಷನ್ ತಗೊಂಡಾಗ, say example, so this is one of the solution. So consists of two particles, that is component 1 and component 2 ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. One is referred for solvent and 2 is referred for solute. So ಇದರಲ್ಲಿ solvent ಮತ್ತೆ solute ಇದೆ. So ಇದರಲ್ಲಿ solute particles ಎಷ್ಟಿದೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಬೇಕು. So ಅಲ್ಲಿ solvent ಇದೆ, solute ಇದೆ. ಈ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್, ಈ ಸೊಲ್ಯೂಷನ್ ಪ್ರಾಪರ್ಟೀಸ್ ಯಾವ್ದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಬೇಕು, that is depends on number of solute particles present in the solution. But remember that doesn't depends on nature of solute. ಆ ಸೊಲ್ಯೂಟ್ ಬೇಕಾದ್ರೆ ಕೋವಲೆಂಟ್ ಆಗಿರ್ಬೋದು, ಅಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ಆಗಿರ್ಬೋದು, ಮಾಲಿಕ್ಯುಲರ್ ಸಾಲಿಡ್ ಆಗಿರ್ಬೋದು, ಅದು ಕಾಂಪೋನೆಂಟ್ ನೇಚರ್ ಏನಾರ ಆಗಲಿ, ಸೊಲ್ಯೂಟ್ ಏನ್ ಬೇಕಾದ್ರೂ ಆಗಿರ್ಬೋದು, ಬಟ್ ನಾನ್ ಆಗಿರ್ಬೇಕು. ಜೊತೆಗೆ ಅದು ನೇಚರ್ ಏನಾಗಿರುತ್ತೆ, ಸಲ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್, ನಂಬರ್ ಆಫ್ ಸಲ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಮೇಲೆ ಮಾತ್ರ ಏನಾಗುತ್ತೆ ಆ ಪ್ರಾಪರ್ಟೀಸ್ ಡಿಪೆಂಡ್ಸ್ ಆಗುತ್ತೆ. ಅಂತ ಪ್ರಾಪರ್ಟೀಸ್ ನಾವು ಕಾಲ್ಡ್ ಆಸ್ colligative properties ಅಂತ ಕರೀತೀವಿ. ಸೊ ಒಂದು ಮಾರ್ಕಲ್ಲಿ ಕೇಳಿದ್ರು, ವಾಟ್ ಆರ್ colligative properties? So that is properties, the properties which depends on number of solute particles relative to total number of particles in the solution. Notice the properties that depends on number of solute particles relative to total number of particles. And total number of particles and solvent is there. Total number of particles, the particles component solvent and particles of component solute. So everything ಸೇರ್ಕೊಳ್ಳುತ್ತೆ. ಆ total number of particles ಅಲ್ಲಿ ಎಷ್ಟು solute particles ಇದೆ. That is the meaning. Number of solute particles relative to the total number of particles in the solution, but not on. And it depends on number of solute particles, but not on the nature of solute particles. But nature of solute particles in the solution. So this is very important for 1 mark. What are colligative properties? So colligative properties are properties which depends on number of solute particles related to total number of particles in a solution, but not on the nature of the solute particles. ಅದು ನೇಚರ್ ಏನು ಬೇಕಾದ್ರೂ ಆಗಿರ್ಬೋದು, ಅದು ನೇಚರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ. ಎಷ್ಟು ಸಲ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇದೆ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಮೇಲೆ ಆ ಪ್ರಾಪರ್ಟೀಸ್ ಡಿಪೆಂಡ್ಸ್ ಆಗುತ್ತೆ. ದೋಸ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ colligative properties. ಇಲ್ಲಿ ಇನ್ನೊಂದು ತರ ಹೇಳ್ಬೋದು, the properties depends on number of solute particles relative to total number of particles in the solution irrespective of the nature of solute particles. Irrespective of that depend ಆಗಲ್ಲ ಅಂತ. So that is ಅಥವಾ it is not depends on the nature of solute particles, and those properties of the solution are called as colligative properties. And remember, in the case of colligative properties, in the study of colligative properties, the solute should be non-volatile. ಅದು non-volatile ಆಗಿರಬೇಕು. And we have to study the 4 important colligative properties. So that is, first one is relative lowering of vapor pressure. That is the one colligative property. And the second one is osmotic pressure. Osmotic pressure indicated by pi. And the third one is elevation of boiling point of solvent. Elevation of boiling point of solvent. That is taken as delta TB. That is boiling, for boiling. And the last one is depression of freezing point. Depression of freezing point of solvent. That is taken as delta TF. And these are the 4 important colligative properties. That is relative lowering of vapor pressure, shortly called as RLVP. Relative lowering of vapor pressure and osmotic pressure, that is pi. So in this we are going to study the osmosis also, and elevation of boiling point of solvent, that is how the boiling point of solvent increases in the presence of solute. So a depression of freezing point of solvent. Depression is nothing but decreasing in freezing point of solvent by adding non-volatile solute. So those are the colligative properties. And why they are colligative properties? That is, you have to study one by one. So all these properties are mainly depends on number of solute particles, but not on the nature of solute particles. So ಅದು ನಿಮಗೆ ಈಕ್ವೇಷನ್ ಪ್ರಕಾರ ಮಾಡ್ತಾ ಹೋದಾಗ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ಎಲ್ಲಾ ಪ್ರಾಪರ್ಟೀಸ್ ನ ಒಂದೊಂದು ಸ್ಟಡಿ ಮಾಡಬೇಕು, ಜೊತೆಗೆ ಎಲ್ಲಾದ್ರ ಮೇಲೂ ಏನಾಗಿದೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ. ಸೊ ದಟ್ಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ಥಿಯರಿ. ಸೊ ಎಸ್ಪೆಷಲಿ ಫಾರ್ ಥಿಯರಿ ಏನಾಗುತ್ತೆ, 4 ಪ್ರಾಪರ್ಟೀಸ್ ಅಲ್ಲಿ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ನ ಕೇಳ್ತಾನೆ ಫಾರ್ 3 marks. So we have to study the one by one. So now that the properties are discussed in the next class. Thank you.